Okay, I'll start.
Good evening, Evan.
Good evening, everyone. As it says, the title, Making Short Distance Contacts on HF, the Art of Short Skip. Not so much about near vertical incident skywave, although it's a little bit about that, but something a little bit different, as I'll explain. So, what is this talk? Well, basically, I mean, for most people, I think the idea of HF radio is to get long distance over the horizon, particularly well over the horizon contacts, like exotic places like the Andaman Islands, seeing that first map, or the recent expedition to Bouvet, 3YOJ, or 0J, the most remote place on Earth apparently. And the idea is to work these places on as many bands as possible. That's for many amateurs, but not really for everyone. Basically, I mean, to get distance is one thing, is one sort of skill, but it's also requires a bit of skill in knowing what to do to get places which are much closer to us, particularly those places on the high bands. So it might be easy to work Scotland, for instance, on 7 megs during the daylight hours at this time of the sunspot cycle, and on 80 metres at night. But what about on 15 metres during the day or 20 metres at night? Not so easy. And the ladder openings in particular, these are what's called, you know, where you've got the high frequencies on the short distances, and this is what people generally know as short skip, and not always easy to get. Okay, so it might be enough for you just to get, say, Scotland on 40 metres or 80 metres. That's good enough for you as long as you get through. That's the main thing. But what if you say want to gain an award? For instance, you want to get the ARRL's, which is the American RSGB, effectively a 5-band DXCC award, essentially requiring the operator to make 100 contact stations in 100 different so-called DXCC entities. That could be England, Scotland, Balearic Islands, or in some cases whole nation states, on each of the 5 main HF bands. Also, and another thing you get, and it's quite popular for Brits, is getting the Worked All States Award, contacting all US 50 states, again on each of those bands. Now that for us that is DX, but say if you're someone living in Northern California, for instance, who wants to contact Oregon, again that would be easy, say on 80 metres, but not always so on 10 metres. And don't forget the dreaded contesting. So many contests, if not most of them, different on different bands. Okay, so for example, you're working a particular station, a Belgian station, ON6CT on 7 megahertz. That may generate you 3 points, and working the same station later. Thing is as well, and this is the rubber, is some contests will actually add a multiplier element, where if you contact a particular locality like a DXCC entity, you'll get a multiplier if a station in that entity on that band is worked for the first time. So, for example, the CQ Worldwide DX contest, which our contest group does, for example, the first multiplier station that we work in Scotland on 15 metres will generate 1 multiplier, or 1 country multiplier. And with to get the score at the end, the number of points, which generally relates to the number of QSOs, multiply the total number of multipliers, so that's the number of band DXCC combinations and the number of band and CQ zone combinations. We're in zone 14 here in the UK, and that will give you your total score. So essentially, it's worth trying to get, say, Scotland on 15 metres, and not just get on 80 and 40. And even though you may not get many contacts on 15, you'll at least get the multiplier credit. So you'll want to at least sometime find it if and when there's an opening to Scotland on that band. So just quickly, just a bit of a primer on HF propagation for those who aren't sort of familiar how it works so much. Essentially, the skip that we talk about is the result of basically skybound radio signals being redirected back down to strike the ground, usually some distance away. Most people do want it some distance away, and this is by ionospheric refraction. So we've got the ionosphere, which I think we're all familiar with, basically electrically charged air particles ranging, going up in various layers from 80 kilometres right up to 600 kilometres above the Earth's surface. And you look at the figure on the side there. What I've done is I've sort of made it, and so this is a typical path that you get. So from the transmit point to point A would be, I've imagined here, 1,000 kilometres, and that would be typical for a daytime 20-metre signal. So that would be roughly, say, Manchester to Berlin. If you look at the different rays, different signal paths on that diagram there, you look at numbers 1, 2, and 3. Now, if they bent down back to the ground, is that
keep going
on the recording? Okay, just kind of looks me recording in progress, that's all. Yeah, so in each of those rays, if they were bent down to the back down to the ground, they'd hit the ground about 100, 500, 700 kilometres from the transmit point. If that could happen, if that refraction could take place, but in this case, the rays impact the ionosphere far too steeply. In other words, the angle of incidence striking the ionosphere is too high, and they get refracted a little bit, but only slightly, and then carry on into space. Never be seen again. Only really sort of with takeoff angles, we look at ray 4 there, where the critical angle there is at or lower than that of ray number 4, will you result in skip. So you've got to basically, and the first point that hits the ground is point A, 1,000 kilometres away. So there are two ways of looking at this. In this case, the typical skip distance for a 14 megahertz signal around this time of the sunspot cycle during the day is 1,000 kilometres. Looking at the other way, you'd say the maximum usable frequency for a path of 1,000 kilometres at this time is 14 megahertz. So essentially what you want to do is know when that's either, looking at one way, that skip distance drops, the 14 megahertz skip distance drops, or when the MUF over 1,000 kilometres, or MUF at 1,000 kilometres I should say, increases, say 20, 21 or 20, 28 megahertz. Okay, so there's a couple of techniques you can use to do this. The first one would be backscatter. So normally when we talk about skip, that's usually forward scatter. It bounces off the ionosphere, and like at the diagram there, figure A, the top one, it hits the ionosphere and just keeps going in that same direction. And that's what normally happens, and that's normally what we want anyway. Backscatter is when the signal is reflected by the ionosphere and at some point comes back towards the transmitting station. And what I mean by this, looking at an example here, we've got, look at figure B there. So here's a signal from Holland, for instance, hitting the ionosphere, passing overhead of the UK, hitting some point in the Atlantic, and then the signals are reflected back towards Europe and hopefully land in Great Britain. So that's
How can you tell that's happening?
You're getting ahead, Roy.
Sorry. Naughty boy.
We'll edit that out, don't worry.
No, we won't.
Yeah, so normally the Holland to England skip distance or distance is well within, say, the 28 megahertz skip zone, even at solar maximum. You look at, I think Amsterdam's only 600 kilometres away, not far in terms of the HF world. Now you can tell it's backscatter. It's usually a little bit weak and watery and also very echoey. That's quite evident as you hear it, and I'll just go get this point first. It's usually when the ground is ocean, so it connects with say the Atlantic or maybe the Med, I guess. But usually when the swell is quite high, so you get a wave which could sort of effectively reflect back an outward bound signal. Now my experiences with it usually are at the contest station, and so I'm beaming towards America, which is sort of 300 degrees, something like that, azimuth, so away from continental Europe, and then the signal. So really, you've got Holland is like Holland or Belgium, that is A, close, and B is on the wrong end of the beam, and that's another giveaway that it is backscatter, is that you wouldn't normally pick them up with the beam pointing that direction. The thing is also is that because the signal is usually a bit weak once it comes back to you, it's only really with beam antennas that you can pick it up, certainly in my experience anyway. Okay. The other thing is what's called above-the-MUF mode. Now, generally, I think most people would probably understand maximum usable frequency is just that. You can't go frequency can't go any higher for that particular path. And looked at the other way, you can't go shorter than the skip distance. However, the ionospheric layers, if you can see that on the second figure, that the little trace on the right there, the ionospheric layers are not always smooth like they is shown here. The change in the electron density, which is how the ionosphere is defined, in textbook ways will change very smoothly with height. You'll get, when you're in those layers, you'll get increasing electron density, and that's how you get the refraction back down to the Earth. However, that's not always the case, and you may find that in theory you're expecting the MUF to be 21 megahertz for a particular path. Suddenly you find that it jumps to 28. This is an example. And sometimes what happens is you get what's called a bulge or a blob or a cloud of just very high electron density, rather randomly on the upper atmosphere, the upper layers of the ionosphere, and that can result in some of the RF energy actually coming back down to the ground, and perhaps some of that being within the theoretical skip zone, so within our 1,000 kilometres that we're in the example before. The thing is, again, this is usually quite weak, in fact very weak, and I think it depends who does the estimation, but VOACAP, for instance, which is Voice America, model will estimate at least 25 dB loss if the MUF is significantly higher than, if the frequency you're using is significantly above the MUF, I should say. So that's a bit of a hit. But it can be worked, and one reason why people do use antennas with Yagis with lots of elements on them, you know, to get good ERP, is that will compensate for that and pick up even those weak signals. And also, I think it's one of the secrets of the modes like FT8, and that they can exploit this kind of propagation even with relatively low power and and sort of non-fancy antennas, whereas, you know, modes like RTTY CW SSB just doesn't have a hope really. Okay, right, and here's probably the main method to get the short skip, and that's Sporadic E, and I think most people are probably familiar with this. I think I'd define it as a random surging of ionisation, essentially an enhancement of the lowest of the reflecting layers in the ionosphere, the E layer, which is about 100 kilometres above the surface of the Earth. And this allows for very dramatic increases of MUF and alternatively looked at skip distances. Now, we normally talk about Sporadic E really regarding VHF, you know, so 50 megahertz and over distances, you know, sort of. Well, I said about 1,500 kilometres, and also people talk about regarding 10 metres as well over distances, say from here to Germany, for instance. But even small enhancements can be useful. You may find you regularly get 14 megahertz to wherever you're going, but all of a sudden that goes up to 21 because of Sporadic E. What you find is that the Sporadic E clouds are very localised. They're only just little clumps, really, of relatively small area. And one of the another characteristic is that the reflection is specular. So it's basically like reflecting off a mirror. So the RF energy really is that is reflected to a small patch of the Earth. But if you do receive it, the signal strength is usually very strong. But it, on the other hand, either side of it will probably hear nothing. So, for example, you may get a path like from Manchester. All of a sudden, you get a 10-metre contacts open to Slovakia and Hungary, but nowhere else, or say Denmark and Germany, or say the Northwest Balkans like Slovenia, Croatia, and Yugoslavia, you know, Serbia, YU. Sporadic E is random, and it can happen any time of the year, around the clock. But there are certain patterns to it. Looking at the occurrence of it over the year, so seasonally basically, it really gets going in spring. It's really really going now, and lasts all through summer and peaks around the summer equinox, which is later this month. Looking at diurnally across the day, it tends to be a late morning and late afternoon phenomenon, but again I've seen really strong cases of it where the ionisation level just goes through the roof, you know, at 10 o'clock at night. You know, it's just, you just got to catch it when it's there. So how would you detect it? How would you know if that short skip potential, is around? Firstly, there are lots of low power beacons across the EU, only not really on the middle part of the HF spectrum like 14 megahertz or 21, but really sort of certainly a lot on 28, toned on 28 actually, which is obviously what people want. They want the 10 metre openings, and they're most and they're harder to come by, particularly out of the sunspot cycle. Most of these beacons are usually slow speed CW, but also these days they're on Whisper and other WSJT modes. One good source which I recommend people use, certainly if they want to get a program their scanners or whatever for the frequencies, is G3USF's worldwide list of beacons. Just type that into Google and it'll come up, and that's regularly updated. Thing is, I mean, even if you don't know CW, I mean, it's very slow anyway. But you know, if what you're hearing is corresponding to the frequency you're listening to, you know, if it's beacon IZ5 WDD or whatever, chances are you've got the right one. Some of them are very weak, QRPP, I guess you could call them. But if there's an opening there, you should be able to hear them, and they will even appear on a spectrum scope. Just with the weak ones, they can be the trace can be a little faint. There are only a handful in England. I've looked at the 10 metre ones from the USF's lists. One's in Norwich, Worthing, Waddington, and I think most famously at all in mid Cornwall, GB3MCB, which Peter Taylor, our member, is involved with. I'm not sure if he's involved with that one in particular. I think it's more the 6 metre and 4 metre ones, but there's a whole heap of them on that tower. Look, there's just antennas everywhere, isn't it? So I guess, I mean, those ones, I mean, if you want to get 10 metre short skip, you'd probably listen to those. But the good thing really for beacons being based here is that continental stations will be able to hear us and then start calling out. So how do you find these beacons on the bands? The easiest thing is just to spin the VFO in the beacon sections of the bands. That's probably the easiest. I mean, just remember certainly with the 10 metre section, at the moment I think that goes from 28.147, I think that's the lowest one, until to 28.322. So it's a big chunk of the band which you'll have to tune through. The other thing to do is maybe put the selected beacons in your memory bank of your rig or your scanner, whatever you're using, and just slowly scan through them. Just remember they are very slow, and maybe not set the scan speed up too high for those. Another thing to do is you can, with SDRs these days, or rigs with pan adapters, you can watch a large chunk of spectrum at a time. So this is a screenshot of it's SDR Sharp, I think the program used. The right hand side of the scope there is the entire 10 metre beacon band, and as you can see, a few traces are there, and obviously you can match them up to either listen to what they're chirping away on, or look up G3USF's lists. The other thing, I mean, to do, depending on what sort of software you're using, because I use SDR Sharp, and you can put little markers on each of the frequencies and write in the call sign of the beacon, so it's much easier to spot which beacon's chirping and what it relates to. So another thing to do is looking at the internet directly, using that real time. is to look up, use DX clusters. It's basically when people will put their spots of what they've heard on the internet, and you can look, and the whole world and his dog can look that up. The one I use is DX Summit from Finland. I think that's probably the most famous one. And as I was saying, shots of stations, shows reports of stations actually being received, and not just the call sign and who spotted them, but also maybe a little bit of a description as well, and the time also. The good thing about this one is that SSB spots are included. I'm going to talk about the reverse beacon network, which is all automated, and so that doesn't pick up SSB, not yet, until AI starts kicking in, I think. There is, as it says, DX Summit, mainly people report DX, but also plenty of short distance skip as well. That may be unusual. So for instance here, the screenshot in the top right, you can, it's an example where I've set the filters. The filters are quite comprehensive actually, very easy to use. I want to listen for 28 megahertz spots where the receiving country, or the spot where the spotters are in England. And here's a bit of a list there, which I took the other day. You see various ones, you know, Ethiopia. Yeah, again, people report the fancy ones, but and then special events and that sort of stuff. But also some pretty close ones in as well. I think there's one where you can put a filter where you can list where you can list the reports of beacons heard. I think that's particularly useful. And another thing as well, I mean, this goes around the world, but you can just isolate this stuff to say Europe, for instance, so you don't get Latin America and all the rest of it thrown in. You see, you look at the info that's listed. ES indicating Sporadic E. There's a TEP one down there, which is transequatorial propagation. It's funny, on 10 meters. F2 propagation is well listed. So that's quite useful to know. Maybe not so much for VHF, but certainly for VHF, but VHF around Aurora, knowing that people are making contacts via Aurora is, as opposed to anything else, is useful to know. And the thing is, not all beacons are picked up by these automatic skimmers, which I'm talking about in the RBM. Yeah, again, just you are relying on people manually reporting, and sometimes they don't. Okay. The other thing which I use as well, as I was alluding to before, is the reverse beacon network. And this shows the detection of transmitting stations which are being picked up through internet-linked software-defined radios using skimmers, CW skimmer particularly, which is an application which just plucks the call signs of CQ callers out of thin air, basically. It's a miracle. Again, I guess most people use this for DX, but again, whatever it picks up, it will report. So in this, in its current incarnation, the reverse beacon network will pick up CW, RTTY, PSK, and also FT4 and FT8. I think it's a separate window for this. And there you can see in the little selections, you can may as well just select them all if you just want to find out what propagation is doing. You can, I mean, it's a bit small to see from there, but you can choose. There's plenty of ways you can filter this by call sign. If you just want to, you can put your call sign and see how you do, where you get when you call CQ. You can isolate it to particular DXCCs, ITU zones, CQ zones, continents. that sort of stuff. That's on the receiving side, the spotting side, who your spotter is, and also what they're receiving. So really powerful. So I've got the example here I've shown is that I set this up so the it will show only contacts made in Europe and received, or transmissions done in Europe and received within Europe on the 10 metre band late in the afternoon a couple of days ago, which was actually during the NFT contest. So what you find that map at the top with which I've blown up here at the bottom, just a lot of lines. Basically, they're the that's the red dots are the spotting stations, and the blue dots are the transmitting ones, the ones that are being picked up. And you can tell by the paths, you know, each of the individual circuits, if there's a sort of an opening on a particular band. So I've put a circle around what looks to be somewhere in Belgium or northern France, and that is possibly where a sporadic E cloud is, because you're getting contacts from Great Britain into sort of, say, Alpine Europe, and you're getting some contacts from Scandinavia through to France, Spain, etc. There's a bit of a crossover point, so that indicates that there's something going on there. So for us, what that may mean is that 10 metres is probably open from Manchester to maybe northern Italy or something like that. You might want to get on the air and try it. And the other thing, I mean, the thing is, if you get on the air on one of those Digimodes or CW, you'll soon find out if you're being picked up, and that's you can test whether your theory is right, basically. So one of the other good thing is you can not just the map but the actual textual data. So it not only gives you the frequency, the time, who's received you or whatever, but also the signal to noise ratio that you've been picked up at. And obviously the higher that number, the better the path is. What I find is that you can get wildcard results where you may, a German station says, oh, I'm hearing it 52 dB, but it's the only German station that hears you. So that's probably not an opening. That's just a fluke, maybe. So it's got to be. If you see a pattern there, then it's all the more likely there is an opening. Let's let that continue. And just looking at a very short skip. So this would be, is there an opening on 20 metres from G to GM, from England to Scotland? And there was one which I picked up again on field day. Plenty of activity on CW, so these things you could find out. And you can see there's one from southern England through to sort of lowland Scotland there, isn't it? Edinburgh, Glasgow, around there.
That Edinburgh station seems to be working a lot.
Yeah.
So I wonder what the thing is as far as he's concerned.
Yeah, I'd imagine he's one of the bigger field day stations, probably with some Yagis and a bit like what we've got. Is he one of the spotters? I think he's one of the spotters. It's a red dot, isn't it? I'd imagine those southern ones are probably the big ones. In fact, there's the East Anglia. That might be M1. Was M6T or something like that. I don't know if they do field day or whatever. Anyway, but certainly from lowland Scotland to southern England, there's an opening there. Again, if you look at the textual data, you see who they are, the spotted and the spotted, and how, and you look at the signal and noise ratio is obviously very, very strong. In fact, that for certainly for DX, you want to, it's more. I find this more useful with DX, is that say if you're working in the USA, If you're getting, say, big stations like K9, K1LZ or something like that being received in the UK, and they're only sort of 10, 9 dB or something like that, with your petty little station, don't bother working. the opening's not quite there yet. But as that number sort of climbs into the 30s, you know, that's when you start knowing an opening for a little station is available. But it's really, really, really good tool. In fact, there's probably too much information on everything. Okay, the other thing is that I use is DX maps, and essentially it shows you the free, but you have to register. I think they're just reported QSOs. I'm not sure if any of them are automated or anything, but the map seems to be a little bit simpler and a better detail than the RBN. It's just a matter of clicking on the band that you want to listen to, what you want to look for, and look at the traces of the contacts. So this is 10 meters. You can see you just click the 10 meter tab at the top, and so this is example again on early in the evening on field day, and you can again, that's around the time I use the RBN for this as well. You can show a sort of stream in from southern England through to northern Italy, and also from the Balearics to Holland. Obviously there's a little bit of a crossover point there, and that to me would indicate there's a Sporadic E cloud in that circle there. So yeah, so this is DX Summit. Yeah, again this is unfiltered. Again, you notice the kind of spots you get are the things like special events, DX, like there's Georgia being reported from Lithuania, etc. So for example, we want to find out any sort of 10 meter goings on within, say, the beacons, just to hear what beacons are reported, and we can go just into Europe, set filters, and here we go. So we've got GM8 LFB hearing someone in Belgium, hear a beacon in Belgium, and someone similar guy hearing one in Germany, and he's reporting it's Sporadic E. There's also one in Italy. So it looks like there's some Sporadic E around, which we'll check on the DX maps at some point. So I think that's quite useful. And the thing with the beacons, I mean, I'm raving on about beacons, but because they're transmitting all the time, as opposed to people just sort of randomly, I'll go on 10 meters because I think it's open. You know as soon as there's an opening if the beacons are being picked up, and then you may start seeing some QSOs being made and a trend sort of happening. But yeah, I think that's quite good, and this is particularly useful for Aurora. There's a bit of a digression there. Yep, so that's I'm going to just take it off the beacons.
Make Stephen happy and have a look at 6.
Have a look at 6.
See, now he's just bought a new antenna.
He'll leave now. Seems VHF. Should really be under HF 6 meters.
I make Steve not big. I've got 11 meters.
Oh, bloody hell. He can clear off then anyway. Right, here we go. It's FT8, so that doesn't count. Yeah. So that's showing what's happening. I mean, again, this just proves that FT8 is probably exploiting that above-the-MUF mode. You see there's a lot of FT8 there, but nothing much else. So, yeah. I mean, it may not give you an idea of what the mode is necessarily, but you can usually tell by the frequency anyway.
Exactly.
Like 313, 5313 is obviously FT8.
Last night, Evan, it was magical on 6.
Right, okay. We'll look up.
Absolutely magical.
One thing that DX Maps does, oh no, sorry, no, there's another program, Make More Miles on VHF, which has historical maps like the one I showed. I'll have a look at last night. Yeah, so that's not much on 50 metres on any real modes there, unfortunately. Yeah, okay. The RBN's a bit more complicated, so I'll get into that. So I don't know how well you can see the thing there. You've got a choice of bands. Basically if you leave all those blank, it picks up everything. It says, you know, just pick up everything. But say if we want to look at 10 metres, people calling CQ, whatever mode it is, that's cool. The spotters are in this country, in the UK, or in England anyway. And we'll just put it anywhere. See what we pick up. We could use that to just isolate, say, signals from Europe. We might do that. So in the last, say, 20 minutes.
Do you want to allocate beacons as well?
Yeah, can do that, yeah. In fact, tick everything.
Is that the one next? Yeah, that's it.
The NCD XF are the special Northern California DX Association beacons, which are quite useful, and they go from, I think it's bottoms 14, then 18, 21, 24, etc. And there are a number of beacon sites around the world, and they're on regular times at regular power levels, and you can really useful for testing if there's openings, particularly for DX. Anyway, that's sorted.
We used to work that fella in backpackers, GW4ZFE.
Oh right, yeah, it's famous. One of the hierarchy. There's not much happening there, but again, you from that spot on DX Summit, there was some sort of path to Germany, wasn't it? GB010 was picked up. So there's a bit there, but not much. Although there is you look at the signal to noise ratio for a couple of these German ones, that would indicate that from southern England at least there's an opening to Germany on 10. Whether you'll get much is anyone's guess, but there's something there at the moment, and probably stuff to the south as well. Spain. And it's quite common. I mean, the patterns that I see for Sporadic E generally is to the southeast, is like to Alpine Europe, or really to Spain, across to the Bay of Biscay. But that's probably just my bias, I don't know. But it can happen anywhere. But generally it does happen towards the south, more than I think to the north. Right, so that's 10. Let's see if anything's on 6. See, that's everything else. A couple of bits there. You see 25 dB, 20 dB. Oh no, actually that's 20 dB into Portugal. So that might be something there. Yeah, so that is quite useful. It's something, I mean, I use it at the contest site for just seeing, I mean, I type in, which is a good thing to do here. What we'll do, I'll clear this. You can type in your own call sign and see how well you go. But what I'll do, I'll just put G5O portable and do it for the last 100 hours, something, isn't it? The last one, when the contest was on, and we'll look at where we got to on 10.
Nothing westwards.
Yeah, I certainly didn't point it westwards anyway. The 10 metre thing.
So
It's a European contest, really. I think I've got a couple on 20 to these states. But you see, it's mostly.
Got into Africa though, didn't you?
Yeah. Picked up mostly sort of Central Europe, but there was a time where it was getting into Germany, and the key point of Germany, certainly for contests like CQ Worldwide, WPX and Field Day, is that there's a lot of stations and a lot of potential multipliers. So if you see an opening there, so particularly on a rare band like 10, work it. And so once I use this to say, right, okay, I've got an opening on 10 to Germany, bang, got on the band and fired away, CQ. I think these ones like to the east, Bulgaria, etc., probably normal F layer, that sort of distance. But E layers is the closer in stuff. Okay, so that's the reverse beacon network. And the other thing as well is that you can download all the spots on a particular day. Thing is for CQ Worldwide, something that's overloaded, but
I'm saying we got enough room for that.
well, has Excel got enough room? That's the main thing. So you look at Saturday the 3rd and Sunday the 4th. You see they're quite big files. That's V8. That's NFD.
Go on, what about the week before?
And the May. End of May. I mean, you can actually paste the data because it comes as a CSV file of all that, that tabulated information as a CSV file, and you can paste it into Notepad, but it's too big for Excel. I don't know how you get around that.
Use the small SQL program.
Right. Okay.
And then put queries on it.
Yeah, it's obviously that.
Sprint SQL or something like that it's called. It's
Right.
a small version. It's free.
Right. We can go to the DX maps. But you see here, we're talking about those beacons being heard in Belgium and Germany from the UK. Here's probably the culprit, and I think that's a Sporadic E cloud. So
Right,
here the 10 metre, it's the 10 metre map here. We'll look at 6 if you like. So
Why not?
VHF.
We do 6.
Yeah, well, I'll VHF it up. 6 metres. Oh yeah. Interesting.
Yeah, that's about right.
Yeah, so people getting in from more than the Northern Ireland to Europe. I think the cloud's probably a little bit too close for us.
Oh no, it's not.
Oh yes,
For
it is.
FT8
Oh
maybe.
no, it's not.
FT8 might be all right.
G0 MRF rings a bell.
Yes, there's not many G stations there, but there's GIs which are working that. Again, I'm not sure if this includes FT8. I don't think. Just take out Whisper.
See that M0N at TNX that you just got rid of?
Yeah.
They're a contest group.
All right.
Um,
Take out digital. Yeah, taking out digital. That's so. This is the skip modes, and yeah, there's still some Sporadic E around there. G3 YLA. That's Jim Bacon, isn't it?
It is indeed.
Propagation Guru.
But M0 TNX, I had a look at that today. It's a contest group.
Right.
10 contest group apparently.
Okay. Were they
They're not far from
Southport
here.
or something?
Around that area, yeah.
please be on it. Please be on it.
Now, just Stephen, you said you had a good 6 metre thing yesterday, didn't you?
Oh, 6 meters was amazing yesterday. I've not seen the 6 meter band buzz like that on FT8, admittedly, but I've not seen it buzz like that for a long time.
Right. So here we
And
are.
that was kind of, I mean, I'm a good tracker, so I can remind myself. Something along the lines of Germany, um, the Ukraine, the first contact I had was in Serbia. It was all over the place, and it was really buzzing. It was really busy.
Yeah,
It was fantastic.
yeah.
There's
Well,
a 6 metre 3-element beam going cheap.
I've got a Halo.
Hello.
I know, yeah. I've got a Halo, and it's actually pretty good. I'm really impressed with it.
yeah. See, there's
It's next to the mattress I need to get rid of.
No, I just put a hole in the roof, Stephen, and put it on that.
yeah. Yeah, I'm not sure if this what modes this uses, but yeah, it's you're obviously getting into Southeast Europe a bit, aren't you? Here from the UK.
Wonder what Carsten was doing.
Yeah, and there's a bit of crossover point there. But again, your FT8 can do a lot more than usual modes. It's a lot more robust.
Honestly, it was absolutely buzzing last night. I mean, right at the moment, 20 meters is really buzzing. I know that because I'm on it. But it was like that on 6 last night. It was just solid.
Were you only doing FT8 or were you doing sideband as well?
I was only playing for a short time.
Right.
I was only playing for a short time. I did try and get in on sideband. I couldn't hear anything. I think that was mostly because I don't really understand 6 when it comes to a sideband. When it comes to sideband, I understand some of the other things. But I'm not quite used to the channels that there are on 6. I know there are certain channels which are just for intercontinental use, which you aren't allowed to have local contact on. So
Yeah, it used to be sort of around 5110. I think that was the DX, the DX part of the SSB band. But above that, I think up to about 250 was the sideband component. I'm not sure if that's still true, but you just scan through that, and if you hear traffic, then it's obviously open, and if it's not, it's not. Yeah, but sideband, the skip really has to be there for it to work.
yeah, it took all, as I say, it took all 30 seconds turning FTA on and tuning the antenna, and you see wall to wall, and you never see that.
Yeah.
It was just pretty good last night.
Yeah. Wow. Yeah. Okay. Oh well. That's all I've got to show, really.